A function is defined to be an even function if f of negative x equals f of x. That's saying that the y coordinates, so these f of negative x and f of x, those are y coordinates. So the y coordinates are equal whenever the x coordinates are opposites. That generates a graph with y-axis symmetry. So another way of describing an even function is to say that it has y-axis symmetry. A function is defined to be odd if f of negative x equals negative f of x. So that's saying that the y coordinates are opposites whenever the x coordinates are opposites. That generates a graph with what is called origin symmetry. So in order to test to see if a function is even or odd, we start by evaluating f of negative x, because we'll notice that that is part of both of the definitions. We have f of negative x in each one. If it turns out that our evaluation gives us the same as our original function, f of x, then it's an even function. If we get the exact opposite of our original function, then it's an odd function. If we get something else, then it's neither. And so let's take this one here and start by evaluating f of negative x. So that's telling us to replace the x with a negative x. Well, when we square negative x, that's negative x times negative x. That negative times negative is positive x squared. So it's the same as x squared. And the plus 6 doesn't change, so this is exactly equal to what we started with. So this is f of x. And therefore, by definition, this function is even. Now, a shortcut when we're dealing with polynomials is that if all of our exponents are even numbers, then we're going to get an even function. Now, there's no variable in this last term here, the 6, but I could view that as an x to the 0 power, since anything to the 0 power is 1, and 0 is an even number. So I have an exponent of 2 and an exponent of 0 on the variables. Those are both even, so it's an even function.